In the mid-6th century, an invisible enemy appeared, altering the fate of the Roman world. By some accounts, entire cities lost half their populations in a matter of weeks. The historian Procopius described deserted streets, overflowing cemeteries, and civic collapse. For centuries, scholars debated what kind of disease could wreak such havoc, and whether the accounts exaggerated its cruelty. Now, modern science has answered the question. From a mass grave in the ruins of Jerash, Jordan, researchers have extracted ancient DNA from the teeth of plague victims. The results revealed the unmistakable genetic fingerprint of Yersinia pestis, the bacterium that later fueled the Black Death. For the first time, the cause of the world's first recorded pandemic has been proven beyond doubt. But this discovery raises deeper questions. How did the disease spread so fast in an ancient world? Why was it so lethal? And what lessons does this first pandemic hold for us today? The mid-6th century was an age of transformation. The Roman Empire, long fractured, was re-emerging under the rule of Emperor Justinian I in Constantinople. His ambition was nothing less than the restoration of Roman glory, reconquering Italy and North Africa, codifying Roman law, and building monuments like the Hagia Sophia. To the casual observer, the empire looked strong, outwardly flourishing after centuries of turbulence. But beneath the surface, the Mediterranean world was tightly interwoven in ways that made it uniquely vulnerable to crisis. Trade bound distant regions together like never before. Grain shipments from Egypt sustained Constantinople, spices from India, silk from China, and furs from the northern forests flowed through vast networks of ships and caravans. The Red Sea and Persian Gulf were busy arteries linking the Mediterranean with the Indian Ocean. This interconnectedness brought prosperity, but it also carried hidden dangers, the rapid spread of diseases far from their place of origin. Urban life magnified the risk. Constantinople, Antioch, Alexandria, and other cities teemed with hundreds of thousands of people living in dense quarters. Poor sanitation, reliance on cisterns, and close contact between humans and animals created ideal conditions for contagion. The empire's military campaigns, too, moved armies, and the rats and fleas that traveled with them, across regions in constant flux. Beyond the empire's borders, climate instability added another layer of stress. Modern studies point to a late antique Little Ice Age, beginning with the massive volcanic eruption of 536 CE, which dimmed the sun for over a year. Harvests failed, famines spread, and populations weakened. Malnourished bodies provided poor resistance to disease. Political turmoil in Persia, Arabia, and the steppe added further instability to an already fragile system. It was in this interconnected, crowded, and stressed world that the first great pandemic would strike. When it did, the speed and scale of devastation would shock contemporaries and puzzle historians for more than a millennium. But before science could uncover the microbial culprit, we must first turn to the words of those who lived through it. Their writings give us the earliest clues to what this mysterious plague looked like. The first reports of the 6th century plague come from those who witnessed it unfold. Chief among them was Procopius of Caesarea, a court historian attached to Justinian's government. In his accounts, he describes the sudden arrival of a disease in Constantinople around the year 541. He wrote of fevers, followed by swellings in the groin, armpits, and behind the ears, symptoms that align closely with bubonic plague. The scale, he claimed, was almost incomprehensible, 10,000 deaths per day at the height of the outbreak in the capital. Other voices echoed Procopius. John of Ephesus, a churchman writing in Syriac, recorded entire towns left desolate, with corpses stacked in the streets. Evagrius Scholasticus, who lived through multiple waves of the pandemic, described losing his own family members to the disease. These testimonies paint a picture of terror, but they also raise questions. Did the figures exaggerate reality for dramatic effect? Were these writers interpreting disaster through the lens of divine punishment rather than medical observation? Medieval chroniclers often mixed the miraculous with the factual, making it difficult for modern historians to distinguish metaphor from reality. The suggestion that the plague killed half the population of Constantinople may not be literally accurate, but it signals that mortality was on a staggering scale. Even the simple act of describing swellings is crucial, It provides a direct link to what we now recognize as buboes, the hallmark of Yersinia pestis infection. For centuries, scholars debated whether these written sources described plague at all, or some other disease such as smallpox, typhus, or anthrax. Without direct biological evidence, the texts remained ambiguous. They told us that something catastrophic had happened, but not with certainty what pathogen caused it. It is here that archaeology and genetics entered the story. Only with the recovery of ancient human remains could scientists finally move beyond written testimony and test the bones and teeth of victims for biological traces of the disease itself. That step would eventually provide the decisive breakthrough. Before the latest discoveries in Jordan, the case for the plague of Justinian being caused by Yersinia pestis rested on a patchwork of genetic clues. Over the last 2 decades, advances in ancient DNA analysis allowed scientists to extract and sequence genetic material from human remains dating back more than 1,000 years. Teeth, in particular, proved valuable because their dense structure protects microbial DNA long after soft tissue has decayed. The first hints came from burials in Germany, France, and Britain that dated to the 6th and 7th centuries, the same period as the Justinianic pandemic. Researchers recovered fragments of Y. pestis DNA from skeletons in these graves, showing that the bacterium was indeed present in Europe at the time. These findings were a breakthrough. They established that plague was circulating during late antiquity, lending credibility to the ancient written accounts. Yet, there were limitations. The genetic material was often degraded, leaving researchers with only partial genomes. This meant they could confirm the presence of the pathogen, but not fully reconstruct its characteristics. Moreover, none of the evidence came from the Eastern Mediterranean, the region where the pandemic is thought to have begun. The absence of direct material from the supposed epicenter left a lingering doubt. Another challenge lay in the complexity of Y. pestis itself. The bacterium has undergone multiple evolutionary changes over thousands of years, producing different strains with varying degrees of virulence. Without complete genomes, it was difficult to determine whether the strain circulating in late antiquity was the same as that responsible for the Black Death 8 centuries later, or whether it had unique features that made it especially deadly in its own time. So, while these early studies established a tantalizing link between plague and the Justinianic pandemic, they left historians and scientists unsatisfied. The evidence was suggestive, but incomplete, more a trail of breadcrumbs than a solved mystery. To answer the question definitively, researchers needed a site where victims could be clearly identified and where the preservation of DNA was strong enough to reconstruct entire genomes. That opportunity would come from an unexpected location, the ruins of Jerash in modern-day Jordan. The turning point came from a remarkable archaeological discovery in the city of Jerash in present-day Jordan. Once a thriving Roman and Byzantine settlement, Jerash had been heavily damaged by an earthquake in the mid-8th century. But beneath its ruins, archaeologists uncovered something even more striking: a mass grave dating to the 6th century, the era of Justinian's plague. Unlike normal burials, this pit contained hastily interred bodies, laid without ceremony. The unusual context suggested an event of sudden, catastrophic mortality. When scientists examined the remains, they turned to the teeth, the best reservoirs of ancient microbial DNA. From several individuals, they successfully extracted genetic material that, once sequenced, revealed a familiar culprit, Yersinia pestis. But this time, the evidence was far more complete than in earlier studies. Researchers were able to reconstruct nearly identical plague genomes from multiple individuals, confirming that they had all died in the same outbreak. This was decisive for 2 reasons. First, it placed plague directly in the Eastern Mediterranean during the mid-6th century, precisely where historical sources describe the first wave of the Justinianic pandemic. Second, the uniformity of the genomes showed the speed of the outbreak. The individuals in the Jerash grave likely died within a short span of time, infected by the same strain, rather than representing sporadic or unrelated cases. The discovery settled a long-running debate. For decades, some scholars had doubted whether the written accounts of the plague of Justinian referred to bubonic plague at all, suggesting instead diseases like smallpox or measles. With the Jerash DNA, those doubts were put to rest. The first pandemic was unquestionably caused by Y. pestis. Yet the Jerash evidence also raised new questions. If this was indeed plague, what made it so devastating compared to later outbreaks? How did this strain move so quickly across continents, and why did it inflict such staggering mortality? To answer that, researchers turned to the biology of the bacterium itself and to the environmental and social conditions that allowed it to thrive. The DNA from Jerash confirmed the identity of the pathogen, but understanding why the pandemic was so devastating requires looking at both biology and context. Yersinia pestis is a bacterium with a well-documented capacity for destruction. Transmitted primarily by fleas carried on rodents, it can infect humans in three main forms: bubonic, septicemic, and pneumonic plague. The most common bubonic plague produces the swollen lymph nodes described by ancient writers. But if the bacteria spread to the bloodstream or lungs, the disease could become rapidly fatal, sometimes killing within days. What made the Justinian strain so lethal? Genetic studies show that the lineage circulating in the 6th century was an early branch of Y. pestis. It possessed many of the same virulence factors that fueled later pandemics, including genes that allowed it to evade the immune system and survive in flea vectors. This meant populations encountering it for the first time faced a novel pathogen with no inherited resistance. In a world without antibiotics or effective medical intervention, the consequences were catastrophic. The environment compounded the danger. The mid-6th century was marked by climatic instability, beginning with the massive volcanic eruption of 536 CE that triggered years of cooling. Harvest failures followed, leading to famine and malnutrition. A weakened population was more susceptible to infection, and communities already on the edge of survival were devastated when plague arrived. Human networks amplified the spread. Constantinople, Alexandria, and Antioch were densely populated hubs connected by constant trade. Grain shipments from Egypt carried not only food, but also rats and fleas into the heart of the empire. Armies on campaign, merchants on caravans, and sailors along sea routes all acted as unwitting carriers. The disease moved faster than imperial authorities could respond. Unlike later medieval outbreaks, the Justinianic pandemic struck a world that had no cultural memory of plague. People had no idea what they faced, and responses ranged from desperate prayers to mass burials. Without organized containment or understanding of transmission, the pathogen exploited every vulnerability. The result was not just a health crisis, but a demographic shock of immense scale. But the biological story of the plague is only part of the picture. To fully place the Justinian pandemic in context, we must examine where it sits within the broader evolutionary history of Y. pestis itself. The discovery of plague DNA in Jerash did more than confirm the cause of the first pandemic. It allowed researchers to place the Justinian strain within the broader evolutionary history of Yersinia pestis. By comparing the genomes from Jordan with other ancient and modern strains, scientists reconstructed the bacterium's family tree. This revealed that the Justinian lineage branched off relatively early, representing one of the oldest pandemic-causing strains yet identified. Plague's origins stretch back far earlier than the 6th century. Ancient DNA studies have traced Y. pestis to at least the late Neolithic and Bronze Age, more than 4,000 years before the time of Justinian. In its earliest forms, the bacterium lacked key genes for flea-borne transmission, suggesting it spread differently, perhaps directly between humans. Over time, Y. pestis acquired genetic traits that allowed it to survive inside fleas, transforming it into the efficient killer responsible for historical pandemics. The Justinian strain belonged to a now extinct lineage. After burning through populations across the Mediterranean and beyond, this branch of the bacterium eventually disappeared, leaving no direct descendants among modern strains. Its extinction highlights a key feature of plague history. Pandemics emerge, flare with devastating force, and sometimes vanish entirely, only for new lineages to appear centuries later. The Black Death of the 14th century, which killed an estimated 1/3 of Europe's population, was caused by a different branch of the Y. pestis tree. Yet, when researchers compared the genetic makeup of the Justinian strain with that of medieval and modern plagues, they found striking similarities. Many of the virulence genes were already present, meaning the capacity for large-scale devastation was encoded in the bacterium long before the Middle Ages. This continuity helps explain why the Justinianic pandemic was so deadly. It was not a weaker precursor, but already a fully equipped pathogen. What varied across history were the human and environmental conditions, climate shifts, trade networks, nutritional stress, that determined how hard the disease could strike. Having placed the plague within its evolutionary timeline, we can now turn to the consequences it left in its wake. For the Byzantine world and beyond, the pandemic was not just a biological event, but a profound social, political, and economic rupture. The biological force of the Justinianic plague was only the beginning of its impact. The pandemic rippled through the Byzantine Empire and beyond, destabilizing societies that were already under strain. Contemporary sources suggest that Constantinople alone may have lost a significant fraction of its population in the first wave. Whether or not the figures are exact, the disruption they describe is unmistakable. Fields left untilled, markets emptied, and tax revenues collapsing. For Justinian's government, the timing could not have been worse. The emperor was in the midst of ambitious military campaigns aimed at reclaiming former Roman territories in Italy and North Africa. Armies relied on steady supplies of men, grain, and money, all of which became scarce when the plague struck. Campaigns faltered, conquests were harder to maintain, and the empire's resources were drained by both war and disease. Some historians argue that the pandemic permanently weakened the Byzantine state, leaving it less able to resist future challenges from Persians, Arabs, and later, emerging powers in the Mediterranean. The economy suffered in more subtle ways. Labor shortages drove up the value of workers in some regions, while trade networks contracted under the pressure of repeated outbreaks. Egypt, the empire's breadbasket, was particularly affected. If harvests failed due to both climate stress and lack of labor, shortages rippled outward to urban centers that depended on grain shipments. This combination of famine and plague created cycles of scarcity that lasted for decades. Cultural and religious responses also reveal how deeply the pandemic shook society. For Christian chroniclers, the plague was often framed as divine punishment, a scourge visited upon humanity for sin. Such interpretations shaped ritual practices, including mass prayers, processions, and appeals to saints. At the same time, the presence of sudden death influenced art, literature, and collective psychology, leaving behind a legacy of fear and moral questioning. What makes the Justinianic pandemic remarkable is that it was not a single event, but a series of recurrences stretching over 2 centuries. Even as populations recovered between waves, the reappearance of plague again and again hindered demographic and economic growth. This prolonged instability shaped the course of Mediterranean history, making the first pandemic not just a medical disaster, but a turning point in the fortunes of empires. The study of the Justinianic plague is not simply an exercise in historical curiosity. It provides valuable insights into how pandemics emerge, spread, and reshape human societies. By examining the past, we can better understand the vulnerabilities that still exist today. One lesson is the role of interconnectedness. The Byzantine world was bound together by trade routes, military campaigns, and urban centers. These same networks that enabled prosperity also accelerated the spread of disease. The parallel with the modern world is clear. Globalization makes us wealthier and more connected, but it also allows pathogens to cross continents in a matter of hours. COVID-19 demonstrated how quickly a novel infection can travel across borders, a dynamic that echoes what grain ships and caravans did in the 6th century. Another lesson lies in the interaction between environment and disease. Climate disruptions in the 6th century weakened agricultural output, malnourished populations, and created ecological conditions that favored rodent and flea populations. Modern parallels can be seen in how deforestation, urbanization, and climate change are altering the habitats of disease-carrying animals, increasing the risk of zoonotic spillover events. In both cases, environmental stress heightened vulnerability to new pathogens. Genomic research also shows us that pandemics are not isolated anomalies, but part of a longer evolutionary process. The Justinian strain of Yersinia pestis eventually vanished, but new lineages emerged centuries later, causing fresh catastrophes. Similarly, viruses and bacteria today continue to evolve, producing new variants and at times entirely new threats. Ancient DNA reminds us that pandemics are not one-time events, but recurring features of human history. Finally, The social consequences of the Justinianic plague illustrate how disease can magnify existing weaknesses. Political ambitions faltered, economies contracted, and faith communities sought meaning in disaster. In our own time, pandemics expose divisions in public health access, governance, and trust. Just as Byzantines struggled with explanations and responses, so too do we wrestle with misinformation, political disputes, and uneven resilience. Studying the first pandemic underscores a sobering reality. Pathogens exploit the fault lines of human societies. By understanding how this dynamic played out in the past, we may be better prepared to face the pandemics of the future. For centuries, the plague of Justinian stood as a mystery. Chroniclers described its horrors in vivid terms, yet doubt persisted over what disease they had truly witnessed. Some scholars dismissed the accounts as exaggerated or symbolic. Others proposed alternative pathogens. The debate lingered until the tools of modern science finally allowed us to test the past directly. The DNA recovered from the graves of Jerash provided the decisive answer. By revealing the genetic signature of Yersinia pestis at the heart of the first pandemic, researchers bridged the gap between ancient testimony and biological proof. The result is a clearer picture. The pandemic that shook the Mediterranean world in the 6th century was not an imagined catastrophe, but a genuine plague outbreak with profound consequences. The discovery also reframes our understanding of history. The pandemic was not just a background event in Justinian's reign, it was a central force that influenced the empire's economy, military ambitions, and resilience. Its echoes reverberated far beyond Constantinople, shaping the trajectory of Europe, the Near East, and North Africa for generations. At the same time, the story is a reminder of patterns that transcend eras. Pandemics are not random interruptions, but recurring events tied to the ways humans interact with one another, with animals, and with the environment. Trade, travel, and urban life, the hallmarks of civilization, also create openings for pathogens. Climate stress, malnutrition, and social upheaval amplify their effects. By uncovering the genomic fingerprint of the Justinianic plague, science has given us more than a historical solution. It has provided a cautionary tale. The vulnerabilities that allowed plague to sweep through the ancient world are not so different from those we face today. Understanding the first pandemic is not only about reconstructing the past, it is about preparing for the future.